13. Go too fast here. Let's run our linear regression again. So on this one, I don't see a big change in my y-intercept. 11.2, 10.05, not a great big change. I see a little more change in my slope, not a good deal of change. And going from 0.99 to 0.96 for my r-squared is not a big change. This outlier hasn't changed too much at all. Let me see if I can try to graph it. Yes. To calculate what? No, you look at, the calculation you do is a linear regression, and you compare the slopes and the y-intercept and the r-squared, but there isn't a 1.5 times AccuR rule. This one's a little more touchy-feely. And let's see, I think my lines are going to kind of get all mixed up on the paper, but let me do something kind of tricky. L1, comma L2, comma vars, y vars, put this in function 2. Okay. So, this top line was the original regression, and the bottom line here was the new regression with this outlier, and you see it's just, you know, pretty close to being the same line. So now I'm going to take an outlier, and I'm going to make one that's really going to mess everything up. Okay? So I'm going to take one that is negative, let's go 25. Whoops, that's not what I wanted. This one. Negative 25 and negative 25. Okay. So what I've done is I've taken a point that is way the heck over here. What do you think that's going to do to your regression line? Screw everything up. What changes do you think that's going to make in your regression line? What do you think about the slope? It's going to change the slope to positive. Let's see what it does. B is now a positive slope. My y-intercept has definitely changed. My r-squared is down to 0.66. So that one was pretty darned influential. Now I'm going to show you one more tricky thing. I want to do something even nastier than that point. Let's go to negative 500. Negative 500. Something really out of line, further than the previous one. So now, instead of the negative 25, I have put in negative 500 as my outlier point. And my slope has gone to almost 1. It's positive. My y-intercept is around 0, but what kind of strange thing do you notice on this one? It's just a really strong correlation. But is there a really strong correlation? No. That outlier, because it's so far away from the pack, and because my statistics for my least squares regression line are based on means and standard deviations, that outlier has basically defined my least squares regression line and has given me kind of a false sense of security about my R squared, about my R, about the goodness of fit of this best fit line. And so it just goes to show you that an outlier can really affect your correlation. But if you only look at your correlation, you haven't seen the whole picture. You better make sure you check the slope and the y-intercept to decide if it's really influential or not, because sometimes it may not affect your R squared, but it has wholly affected the line. So there's the lesson there. That's enough.